we're gonna solve these partial fraction decomposition integrals, okay? And they're easy because, not easy in general, I don't think any of this is easy, but they're easy compared to 3 other types. There are a total of 4 types of fractions or factors you can get here, okay? So let me show you briefly. So there are distinct linear factors. Linear, well, you get this sort, then you come up with that, okay? So these are linear factors because if you plot them, you are going to get, where do I have that? You're going to get a line, not a parabola, okay? They are distinct because x minus 3, x minus 2, they're not the same. Then there is repeated linear factors, right? The same factor. Okay, so they're linear because x is raised to the first power. If you plot this is a line, so it's linear. Okay, and then they're repeated because they're twice. Then there is irreducible quadratic factors. This one is irreducible quadratic factor. This one isn't because this x comes out, x minus 1. That's not quadratic. Okay, there's x minus 1. This is linear, this is linear. This is what's irreducible quadratic factor. This is irreducible because its roots are not real numbers. It's imaginary numbers, and its factors are complex numbers. Okay, I have that here if you're extra curious. These are sorts of factors that would be irreducible quadratic factors. Okay, and then there is a 4th type, which is irreducible repeated quadratic factors. We had repeated linear factor, and this is a repeated quadratic. So this can't be factored anymore. This is quadratic. This is what, well, in fact, this is what makes it quadratic, right? X is raised to the 2nd power. Then this is what makes it repeated because there's 2 of them. 1, 2. Okay, so there are 4 types. And here we're going to get distinct linear factors. So this is why I call this easy partial fraction decomposition problems, because compared to other types within this family of integrals, these are easier. Okay, that's why. So now you know what to expect because there are those 4 types. Okay, let's solve first one first because that makes sense. Copy paste it. Okay, let's forget about calculus. Not permanently, just a little bit. Okay, let's just talk about this fraction right here. Okay, forget about the integral, forget about the dx. There is a fraction here. So I would like to write down something like this. Well, first of all, we recognize that they didn't give it to us factored. They gave us x squared minus 9, difference of squares, right? I can factor it easily. That's not a problem. X squared minus 9 is same thing, exactly same thing as x minus 3 times x plus 3, okay? If you multiply this through, you get this back. Those are the same, okay? In math, always, in your math classes, the big deal is about left side of the equation being equal to the right side of the equation. Here, that's the big deal too. Otherwise, you're saying an incorrect sentence, mathematical sentence, it's incorrect, right? You never want to say 5 equals 4, right? And you don't want to say 1 over 5 equals 4 over 5. That's not true. So here, you don't want to say, since denominators are equivalent, they're exact same, they equal one another, you don't want to say 5 here, right? The denominators better be 1 as well. Okay, so that's the whole process here that we're going to be doing, okay? Making sure that math rules are not violated, but what we want also happens. Because what we want is for this integral to be takeable integral, and I would hate a product of 2 fractions inside of the integral because I can't do anything to that. However, if I had a sum or a difference of 2 fractions, that would be amazing because I can take integral of this, integral of that, and then add them, and that's great. Anytime you have plus sitting inside of the integral, terms being added, you should be happy, okay? So I'm not happy because I have a product right now, but I'm gonna get a sum or a difference. However, If I want to, of course you can split these and say 1 and 1 there, but that's still product. But if I wanted to, instead of that product, if I wanted to put plus, I can't say that this is 1 and this is 1. I don't know what this equals to, and I don't know what that equals to, and I don't even think they're the same number. At least I'm not going to assume that. I'm going to assume they're different numbers, and I know that when I put these two fractions together by finding common denominator and add them, that better add up to 1, right? So that's what I'm going to try to do in the next step. Rewrite this unchanged. This is my common denominator. You see, I gave A x plus 3 because it didn't have that, and B x minus 3 because it didn't have that. Okay, so now think of it however you want. You can either cancel denominators since they are equivalent. X squared minus 9 is exactly x minus 3 times x plus 3. You can cancel them. They're on both sides. Or you can just ignore it and work on the denominator. And look at this. I demand that the right side of the equation, denominator part, equals 1. Okay, that's going to guarantee that I find coefficients A and B such that the whole thing adds up to 1. Okay, and that's exactly what I want so that I don't violate any math rules. Okay, so the way that you do this whenever you have distinct linear factors is usually not by writing down system of linear equations. You do that later when you have irreducible square factors. But here, you just do a simpler kind of rogue math. You eliminate this term to find A, then you eliminate this term to find B. Okay, how do you eliminate this term? Well, x, you know, takes on values from real number set, so it can be anything, right? So then what if I set that equal to 3? That will turn this expression in the parentheses. That will make this 0. B times 0 eliminates B term, okay? So let me try to do that. X equals 3, and anywhere you see x, for now, write down 3 and see what happens. Okay, that's 0, so this whole thing is 0. Now what I have left is, so then A equals 1 over 6. Okay, 1 down, 1 more to go. With the same type of thinking, what can I allow x to equal to so that I eliminate the A term? Okay, well, -3 will do that. So anywhere you get this relationship, copy paste it or rewrite it. And in this case, allow x to be -3. Okay. That turns 0. The entire thing is 0. So I ended up 1 equals B times -6. Okay, B equals -1 over 6. Found both coefficients, exactly what I needed. Now, look how much simpler my integral is going to be now. Okay, this is my new integral, and I already know what A and B are. This is 1 over 6, and B is -1 over 6. Or simply, there's minus here and no negative there, right? Okay, the reason why this trick is so powerful, partial fraction decomposition, is because instead of having product of two fractions in the integral, which is not helpful at all, I have sum of terms. I can take this integral separately, then I can take this integral, and that's it. That's all I need to do. And think about this integral. Of course, 1 over 6 is just a constant that comes out of the integrand, right? That can even come out of the parentheses 1 over 6. So you have integral 1 over 6, 1x minus 3 minus 1x plus 3. Okay? So 1/6 comes out of this integrand, and then integral of this is if you allow x minus 3 to equal u, du is simply dx because derivative of x minus 3 is 1. Anytime du equals dx, u substitution is optional. You can just think of this as 1 unit. Okay, so then 1/6 comes out. I have ln x minus 3 minus ln x plus 3. Constant of integration. You can use log rules and say that this entire thing equals to 1/6 ln x minus 3 x plus 3 plus constant of integration. But this is the final answer, and you can stop there, okay? So this is how you do that. Now let's try to solve the second one. You see, you don't have to have 1 in the denominator. It can be any other number, but whatever number there is, you better get the same number on the right side, okay? Again, we're gonna forget about the calculus. We're just gonna get this part. Oops, copied D. Don't need that, okay? I'm gonna think about factoring this. Well, how do I factor this? Now, I want you to remember this question, okay? What two numbers multiply to -4? And it is -4. I want you to, in your question, integrate this sign that the constant term here comes with, okay? What two numbers multiply to -4? It's not 4, it's -4. Well, you just list them, okay? That's pretty much it. That also add to 3, okay? +3. Okay, that's the question. What two numbers multiply to -4 that also add to +3? -4, +3. Include in your question the signs of this term as well as that term, okay? So you don't make a mistake. These are the factors. Now, you want to ask what number should go here that will ensure that when you put these fractions together, when you add them, you get 5 in the denominator. I'm not going to assume that they're the same numbers. I'm going to say that they're different numbers because I don't know yet, okay? So then I'm going to put them together. You find common denominator, which is x plus 4x minus 1. You multiply a, but what it lacks, which is x minus 1. Multiply b, what it lacks, which is x plus 4, okay? And then just worry about the top part, which is denominator. And I demand that the right side of the equation equals left side, okay? That's going to ensure that I find a and b such that they're going to give me 5. When I open the parentheses and do the whole math, it's going to add up to 5, okay? Yeah, we, again, ignore denominator because they're equal. We factored this expression here and we wrote it in a factored form. It's the same thing, right? So we're going to eliminate a by allowing for just a little bit x to be 1, okay? So if x is 1, what do I have here? A term goes away and I have 1 plus 4, that's 5, right? So then b must be 1, okay? Then let's allow x to be -4. So eliminate b term, right? That is 5 equals a times -4 minus 1. And then b term went away, so that's 0. Well, a must be -1, okay? This is -1, this is 1. Okay, I can take this integral. Notice how both of them are going to end up being ln integrals. Make sure that you write b on top of x minus 1 because that's what you said b was. So don't write -1 on top of x minus 1. No, no. That will give you a mistake. Okay, so that's -ln x plus plus 4 plus ln x minus 1 plus c. Again, you can put this together. Using log rules, this one had negative sign, so that goes in the denominator. This one had positive sign, that goes in the numerator, okay? Simple integrals, these were basic rules of integration. Both of them were ln. After you're able to rewrite this fraction as sum of two fractions, then it's simple. And this part right here, finding coefficients that will make sure that you get the same number here, that's algebra part. Here is what the calculus part resumes. Okay, thank you so much for watching. I hope this was helpful. Bye.